Let's review a little bit. We've been talking about ecosystems and food webs, right? So we had talked about the fact that food webs show energy transfer. So let me go back to the food webs here. So they show the energy that's being transferred from one organism to another. Now notice the arrows always point up. Why do the arrows always point up? Well, they're pointing to the organism that's getting the energy. So when you made your food web, I came around and for a lot of you, I had you switch your arrows because you want it always pointing to the organism that gets the energy. All right. Now, we also talked about the difference between producers and consumers. Remember, producers make their own food and consumers eat other things. So you guys are consumers because you don't make your own food, you eat other things. We talked about herbivores, omnivores, carnivores, detritivores, so what they eat. And we also talked about primary, secondary, and tertiary consumers. So today we're going to talk about something called trophic levels. So you can just keep going in your notes where you left off last time. Unless you like to make a new page, that's totally fine. You can start a new page if you would like. So trophic level. Let's look at this word first. Anyone recognize this first part of the word? T-R-O-P-H. Where have we seen that? We've seen that in the word autotroph and heterotroph from the beginning of the year. So autotroph means self-feeding, right? So it's an organism that can make its own food. So a trophic level means the feeding level. So this is the position that an organism has in a food web. So what is its position? What level is it on in terms of what it eats? So if we look at this food web here, we have a whole bunch of different levels and notice how they arrange them. Here's one level, okay? So sometimes our food webs don't have levels. They aren't arranged this way. But if we do arrange them this way, we can easily see all the different levels. All right, so we have the producers down here mostly, okay, the leaves, the plants, the trees. We have the primary consumers right here. That's the next level because they eat the producers. We have the secondary consumers, tertiary, third level, and then fourth level is called quaternary, kind of like quarter, but a little bit different. So these are all levels. So we can organize our food webs by levels and label the organisms in each level. It's just another way of organizing a food web. Now notice the bottom or the first trophic level is where we have producers. Remember, producers are organisms that can make their own food. We talked about plants. Plants are producers because they make their own food. How do they make their own food? They make it through photosynthesis. So plants are producers. And we also said the bacteria, some bacteria are really special and can make their own food by using chemicals in the environment or compounds in the environment. So we talked about deep sea vents, hydrothermal vents down in the ocean, and how the archaea or ancient bacteria are able to make their own food just by using the stuff that's in the water, the compounds, the carbon, the nitrogen, the oxygen that's in the water. So all producers belong to the first level, okay? We're gonna skip that one because you guys already wrote it down when we talked about food webs. So we said energy always goes from the bottom where the producers are up to the top. So we're talking about energy right now and how energy flows through these different levels. Let's look at this picture really quick. This is showing us energy, okay? Notice it has J's here. J stands for joules. It's a measure of energy. It's a unit of energy, just like how inches is something we use to measure length and height. Joules is what we use to measure energy. Another way we can measure energy is with calories. So when you eat food, calories, that's an amount of how much energy it's going to give you. So here at the bottom with the producers, let's look at this. We have 10,000 units of energy, 10,000 joules. As we move up, we get less and less. Notice it decreases by 1 0 every single time. So here we have 10,000. Okay, our primary consumers only have 1,000 joules of energy. Secondary consumers have 100 and tertiary have 10. So why does our energy decrease? Well, we're going to talk about why it does, but for now, we're just going to write down the fact that energy decreases as you move up the food web. So how do we write this? We write this as 10% of the energy from one trophic level moves to the next. So if I have 10,000 units of energy in the plants, only 10% of that is going to move to the next level. That's why I only have 1,000, because 1,000 is 10% of 10,000. Let me show you a really easy way to calculate 10%. So when we have 10,000, in order to get 10% of that, all we have to do is move the decimal place over 1. So chop off the last 0. Okay, so now we have 1,000. With our secondary consumers, right, we're only going to pass on 10% to the next level. So again, we're going to move the decimal point to the left, 1, which gets rid of this 0. So look, we have 100. So 100 goes to the next level. All right, so let's practice this really quick. Let's say that I have 300 calories of energy, okay? How much energy am I going, let's say this is the producers. I'm going to put a P. I'm doing this all shortcut here. If I have 300 calories from the producer, how much is going to go to the primary consumer, the very next level? Well, remember, I said we had to move the decimal point over 1 to the left, or the easy way is just chop off a 0, chop off the last number. So our primary consumers would have 30 units of energy. What about my secondary consumers? How much energy are they going to have? Right, so we're going to chop off this last 0, so they're only going to have 3, okay? 3 units of energy. So if you notice here that our producers at the bottom have the most energy available. They get their energy from the sun, and they have the most amount of energy available. So I'm warning you, this will probably be a test question, right? So write it down. Which level, or which organisms have the most energy? The producers, all right? So you might be wondering, well, why in the world is there only 10% transferred from one to the next? How come we can't get 100%? Well, I'm going to show you in a minute. So our next title here is why only 10%? Why is only 10% transferred from one to the next? Well, the first reason, let's think about it, all right? The first reason is, let's say you are in this food chain, right? So we talked about the difference between food webs and food chains. Food chain is just a line, right? A food web looks more like a spider web with lots of different arrows going in different directions. So we look at this food chain, and let's say that we are a mouse. We're on the second trophic level. So we have all these mice, okay? Well, the mice eat grass. Are the mice that are living in a forest or in your backyard, are they going to eat all of the grass? I don't think so. Because if they ate all the grass, there wouldn't be any grass left. And then what would happen? They'd probably die, right? Same thing with a snake. Are all the snakes going to eat all of the mice in the world? No. Okay. So it would make sense that only some of the energy from our mouse's level here, from the mice, the second trophic level, only some of that's going to the snake, because some of these animals are going to run away and they won't get eaten by the snake. So they're not going to give their energy to the snake because they ran away and escaped. Some of this grass isn't going to be eaten by the mouse, right? So that grass isn't going to give its energy to the mouse because it's just going to keep growing. So one of the reasons why we only get 10% of the energy moving from one level to the next is because not all of the organisms at a level are eaten. Some of them are going to end up just living their lives. Some of them will end up dying, in which case their energy, they'll decompose, their energy will go back into the soil and the environment, but it's not going to go to the next organism on the food chain if they didn't get eaten by that organism. The next reason why we only get 10% moving from one level to a next. Well, if we think about it, let's say you are a hawk, okay? And you're gonna go eat this mouse, all right? So if you're a hawk and you're gonna eat the mouse, are you gonna eat the whole mouse? You might, right? Let's say, for example, you're a human, okay? And you're out in the middle of the wilderness and you've got to go catch an animal, hunt and catch an animal. Let's say you are hunting a moose. Moose are giant, okay? If you hunt a moose, what part of the moose are you going to eat? You're going to eat the meat, okay? What parts are you not going to eat of the moose? Are there any parts you're not going to eat? You might not eat its antlers. You're probably not going to eat its bones. You might not eat its hooves, right? So some of this energy in the animals is in their hooves, in their bones, but we don't eat those because we can't digest them. So only 10% of the energy goes to the next level because we can't get energy from some of the organism's parts. We talked a little bit about cellulose, how cellulose is the fiber part of plants, and we can't digest cellulose. So that's why cows have a separate stomach. They have more stomachs. They can digest grass. And as we know, grass is a plant, so it has cellulose in its cell wall. We can't digest cellulose, but we still eat plants. We eat fruits, we eat vegetables. Those are plants. We can't digest the cellulose. So some of this energy we don't get because we can't digest it, which is okay. All right, last but not least, let's think about how we use energy. You guys need energy every single day. What do you need energy to do? You need energy to eat, to sleep, to breathe, to move. When you use that energy, a lot of times it's given off to the environment. It's not going to the next animal that's going to eat you. All right, it's not going to the bear that's going to attack you in the woods. That energy is being used by you. So some of the energy is given off as heat, or I'm going to change this and to live. Okay, so some of these organisms, right, you guys know you need to digest food, you need to be able to run, your organs need to function, and because of that, you need energy. So with that, we're going to end with this last slide here. All right. Apparently somebody wrote you a note there. It says, hi, children. So when we look at this pyramid, I'm going to get rid of those words for a second so you don't write them down yet. When we look at this energy, this is showing you the energy. Remember we said 10%. So here we have 10,000 units, 1,000, 100, etc. Okay. So when we look at this, how come we only have 5 levels here, 5 trophic levels? Why can't we have 100? Why can't we have 50? Well, we can't because we only have so much energy. If 10% is going at each level, we end up with 1 at the top. We can't get enough energy for another level, okay? So the last thing I'm going to leave you with here is that the number of levels is limited, or it depends on the amount of energy available. So we only have so much energy, okay? So we're just going to change this. It's limited by the amount of energy available. I like that better. So ecosystems only have so much energy. That energy comes from the sun, and then the producers get it, the plants, but we move up in those levels, and we ultimately can only have so many levels because we only have so much energy.